Okay, so in this second and final video of day 8, unit 4 in geometry, yes, I decided it's only going to take 2 videos. Um, I'm briefly going to talk about surface area regarding polyhedra in general, and then specifically about spheres. So first, let's just talk about polyhedra. We've been over this, right? All surface area it doesn't change. All surface area right, is basically two-dimensional perimeter. Okay, in that instead of trying to find the linear distance around a polygon, we go up a dimension and we're trying to find the two-dimensional space occupied by all of the faces or surfaces on some polyhedron, right? Or to put it even simpler, how many square units does it take to cover a given solid, a given polyhedron, right? So, you know, here we have a triangular prism, right? Because it's a triangular prism, we have, if we do the 2D composite, we have two of these triangles. So we would add that to, well, if we look around the lateral surfaces, we would add that to our rectangles. Now, we can't be certain that all three rectangles are going to be the same, right? It depends on what our two triangle faces look like. Okay, but the point is, right, we would add the three rectangles surface areas, or just areas, to the two triangles, right? Essentially, again, doing what I said when I answered the EQ, two-dimensional perimeter. Same thing goes here. So this guy is obviously a platonic solid, right? It's going to have 12, um, 12 regular pentagons for its surfaces. Okay, and I'm having a brain fart on what this one is called. But anyway, an octahedron. Anyway, dodecahedron. What's the matter with me? Anyway, it's going to have 12 pentagonal surfaces, right? So if we just calculate the area of one of these, right, and we've been over this a million times, the area of a regular polygon, and in this case, this is the area of a regular pentagon. All we would have to do is find this apothem, multiply by the perimeter, divide by 2. That's the area of one of our faces, right? And then we know that there's going to be 12 of those, and then we're good. And same thing for this guy here next to it, his little neighbor. Okay, this is an icosahedron, right? There's going to be 20, um, not Doritos. There's going to be 20 equilateral triangles, right? So we would just do base times height divided by 2 and then just multiply that by 20. I mean, you can deduce surface area and perimeter are the two easiest concepts in Euclidean geometry. I mean, it's very simple and straightforward. Okay, at least for polyhedra in the general sense, right? Now, when we get to something a little bit crazier, namely a sphere, that kind of goes out the window. So we just kind of have to, common sense goes out the window. We're just going to have to use a formula. Okay, and that formula, oddly enough, the surface area for a sphere is simply 4 pi r squared. Okay, and I may do a separate video where this comes from. It comes from doing calculus. I guess that's one way to come up with it. I don't know how they would have derived it way back in the day before Isaac Newton. Uh, no idea. And I doubt if Isaac Newton's ever came up with this. I don't know enough about him to say whether or not he did. But anyway, 4 pi r squared, if we do calculus, this is where we derive it from. We derive it from the area of a circle. Like I said, I may do an extra video just for fun, just to see if I can. But anyway, so just a really brief example. If the Earth's circumference is about 40,000 kilometers, what is its approximate surface area? Right? So we don't even know the radius, but that is the one thing that we need to find out. We know the formula for circumference is 2 pi r. We know that the circumference is equal to 40,000 kilometers, right? And I forgot to boot up the calculator. I didn't think I was going to need it, to be honest with you. But anyway, yeah, I will probably do an extra video, and maybe as extra credit, just have you guys kind of, well, I guess it's pointless to have you guys try to follow calculus. I guess me making that extra video would be me satisfying my own ego. I probably won't even do it. But anyway, so here's our calculator. Okay, so obviously, um, we are going to need to get r by itself. And to get r by itself, we need to do the inverse of multiplying by 2 pi, which is to divide by 2 pi. Okay, and if I divide by 2 pi, that's where I need the calculator, isn't it? Okay, so I'm going to say 1,230,000 divided by 2 times pi. Yes, sir. Yes, sir. So that number looks familiar because I've given you problems regarding the radius and circumference of the Earth before. Anyway, so our radius is approximately, and I don't like that estimate. Really? You're just going to not give me the entire number? Oh, these calculators are so advanced and stupid at the same time. Okay, so, well, I guess it did give me a good enough estimate. So the radius is about, and I already forgot the number, 66.20 kilometers. Right, so now all we've got to do is plug this guy in right here. Yes, sir. Okay, so that's just going to be 4 pi r squared, right? And we'll go ahead and chuck that in the calculator. So 4 times pi times our radius. I'm going to copy and paste because I haven't preached that to you enough. 4 pi r squared. And there we have it. Some giant number that my calculator can't fathom. Okay, I don't know if I can fathom that number. That is 509,295,000. Forgot the rest of the number. 817.89. 817.89 kilometers squared. That is insane. That is the surface area of the Earth, aka the sphere, basically. Okay, so that does it for this video. As I keep telling you guys, because we've laid such a foundation in linear and two-dimensional geometry, taking that step forward into 2 and then 3D is not a big jump. Okay, especially because of how good we are at trig. But anyway, if you have any questions about any of this or anything from this lesson, obviously you know where to find me or shoot me an email. Goodbye.